right, so this is section 3.2, the factor and remainder theorems. And so what we're going to do is we're going to continue to work with polynomials. And our end goal is to figure out all of the zeros of these polynomials. So it's kind of the next like 3 sections that all work towards finding all the zeros. Some of the sections have a little bit of extra stuff kind of added in there. But that's kind of the end goal. So if you kind of wonder where we're headed with these next few sections, that's where we're going. So a little bit between the connections between zeros, factors, and the graphs of polynomial functions. And so we've talked about the zeros. One thing to note is if you plug a 0 into the equation, it will equal 0. It's a solution to where the equation is equal to 0. It's a factor, and if you remember when you put your 0 into the factor, you have to change your sign. And it's also an x-intercept. So there's a huge connection between all of those things that we have kind of talked about. So what we're going to get into now before we actually find the zeros is we're going to talk about how to do some division with some polynomials. So here is the first one. So it says use polynomial long division. So we're going to use long division to find the quotient, that's the answer to a division problem, and the remainder, that's what's left over, when we have 2x cubed plus 3x squared plus 3x plus 4 divided by x plus 1. All right, and so you're going to see this set up in MyOpenMath, and what it's looking for is some very specific things. So the first thing you're going to do is you're going to take 2x cubed plus 3x squared plus 3x plus 4, and we're going to divide it by x plus 1. So that's your first kind of setup there. It doesn't go in the quotient line. That's where your answer goes. And then this will be the work that we'll do to get our final answer. So here's how long division works. You're going to start with the x in this equation, and you're going to ask yourself, x times what is 2x to the third? And so in order for x to multiply to be 2x to the third, it's going to be 2 times x squared. So the first piece of your quotient is a 2x squared. What you're then going to do is you're going to take whatever you put up here and multiply it by both pieces, and those will go in that next line. So 2x squared times x is 2x cubed, which is perfect. We want those to match exactly. And then 2x squared times a positive 1 is plus 2x squared. And then what we're going to do is we're going to subtract this piece here from our original polynomial. So when we do the subtraction, the 2x cubed minus 2x cubed is 0. Those go away. The 3x squared minus 2x squared, this isn't an addum, it's a subtract from the subtract here. When you subtract them, you're going to get just an x squared. And then you should bring these other pieces down. Everything else will just come straight down just as normal because you're not subtracting anything from it. And then you're going to repeat the process. So you're going to go back to your x plus 1. And you're going to ask yourself, x plus 1 times what is x squared? And it's not so much about the plus 1, it's about the x. X times what is x squared? And that would be times x. So plus x up here in your quotient. You're going to multiply again. And now you're going to put those answers in this next available line. So x times x is x squared. X times 1 is an x. And then we'll do the subtraction. X squared minus x squared, those should always simplify because you set them up to simplify. And then 3x minus x is a 2x. And then you still have a plus 4. Repeat the process again. X times what number is 2x? That would be a plus 2. Multiply. 2 times x is 2x. 2 times 1 is 2. Do the subtraction here. You're going to have 2x minus 2x, which is 0. 4 minus 2 with a remainder of 2. So if you take this polynomial here, divide it by x plus 1, this is going to be your answer with a remainder of 2. And so what we can do is we can change the way that this is written into a different format, and that's what you're going to see in the next question. So we're going to do some long division in this next question as well, and then that will change. We'll see what it looks like to change the format. So here we are again. Rewrite f of x, which looks like this, in the form of the quotient plus the remainder over the divisor. And we'll talk about what this piece looks like here. But what we're doing is we're dividing these two to find what the quotient is and what the remainder is. And so we're going to take it from just a single factor and write it separate like this. So it's the same process. Oops. So you're going to take 6x minus 8 and divide it into 18x cubed minus 12x squared minus 22x plus 12. All right, so here we go. 6x times what is 18x cubed? Well, 6 times 3 is 18, and x times x squared is x cubed. And then you're going to multiply this by both. So 3x squared times 6x, that should match this 18x cubed. And then 3 times negative 8, that's negative 24x squared. And remember, you are going to subtract this from your polynomial here. So do the subtraction. So when we subtract, we'll end up with a 0 here. 18x cubed minus 18x cubed is 0. Negative 12x squared minus negative, so that's actually a plus. So that'll be plus 12x. And then everything else, there's nothing to subtract from it, so those two pieces will just come straight down. And then you repeat the process. So it's the same general process, just repeated until you can't repeat it anymore and you have just a remainder. So 6x times what is 12x squared? Well, 6 times 2, so it's going to be a plus 2. And then x times x would be x squared, so that'll be a 2x. And then repeat, multiply here. We'll have a 12x squared minus 16x. And then you're going to do that process of subtracting both. So both pieces will be subtracted. 12x squared minus 12x squared will be 0. That first term should always go away. If it doesn't, then you made a mistake here on your multiplying. Negative 22 minus negative 16. So that would be a plus 6x. Well, that's a plus 16, so it's still a negative, right? Negative 22 plus 16, negative 6. And then plus 12. All right, repeat the process again. Negative, or 6x times what is negative 6x? Well, you have to multiply by negative 1. And we already have the x, so it's just times negative 1. So negative 1 times 6x would be negative 6x. Negative 1 times negative 8 is positive 8. And you have to do this process of subtracting. So these will simplify. Negative 6x plus 6x, they'll go away. 12 minus 8 would be 4, so a remainder of 4. So here's how this looks like, the quotient over the remainder plus the divisor. So the quotient is what you get when you divide. So our final answer would be 3x squared plus 2x minus 1. And then you have plus the remainder on the top. The remainder was a 4, so you're going to have a fraction with a 4 on the top, over the divisor. And the divisor is, what did we divide by? Well, we were dividing by 6x minus 8. So that will just go in the bottom. So if you pick any x value that you want and you plug it in here, you will get the same as if you were to plug it in here. So these two are equivalent. All right, so here is the next one. Find the quotient and the remainder using long division. Slightly different problem here in terms of the fact that the denominator is now has a quadratic in it as opposed to a line. The last two we did were lines. So let's go ahead and get this set up, and then we'll do our long division. So we have 2x squared minus 4x minus 5. The denominator is going to be divided into 12x cubed minus 18x squared minus 42x minus 14. And you're going to do the same process that we did before. So 2x squared times what is going to be 12x cubed. Well, 2 times 6 is 12. And x squared times x would be x cubed. And then you're going to multiply. And here you multiply by all three. So you're going to have three terms here. So you'll have a 12x cubed, a minus 24x squared, and a minus 30x. And then remember, you have to take the opposite of these. You're going to subtract them from that equation. So subtracting, once again, that first term should always go away. We have negative 18 minus negative 24. So it would be negative 18 plus, which would make this a positive 6x squared. Negative 42 plus, again, plus 30. So it would be a negative 12x. And then that negative 14 will just come down because it didn't have anything to subtract from it. And then you repeat. So 2x squared times what is 6x squared? Well, that would be times a 3, positive 3, so plus 3. And then go ahead and multiply. We'll have 6x squared minus 12x minus 15. And remember, we have to subtract all of these terms. So we're going to put it parentheses, subtract. You'll have a 0 at the beginning. This is interesting. That would be negative 12 plus 12. So you'll have 0 of those as well. And then you have negative 14 plus 15, which is just 1. So your remainder is 1. We know we're done because 2x squared multiply into 1. As soon as the power here is bigger than the power in the remainder, you're going to be done. So our quotient would be 6x plus 3. So this is the quotient part. And the remainder is 1. It doesn't ask to write it as the quotient plus the remainder over the divisor like the last question did, but if you did, it would be this plus 1 over this quadratic here. All right, so long division is called long division for a reason because it takes a long time and you have to go all the way through the process. And so there's actually another method that you can use to divide that's a little bit shorter. And it's shorter because instead of using all of the variables, it only uses the coefficients. So instead of having to write x cubed and x squared and x's and all of those things a bunch of times, it's just the number portion. And so here is an example of synthetic division, and we're going to use synthetic division quite a bit, so it's in your best interest to really figure out what's going on here, not just for this section, but literally the next 3 sections. And so we're going to take this cubic function here and divide it by, that is actually x plus 3. Sorry, you can't see that, so divide it by x plus 3. All right, so what we have here is we have this kind of box-looking thing. Essentially, this is like the difference between the division and what we're dividing by, and then this is where your quotient is going to live. It's outside of this box at the bottom. And so if you look at this, the 1 here comes from the coefficient of the x cubed. So this would be 1x cubed plus 8x squared, so the next number is 8, plus 19x, so we have 19, plus 18, so we have 18. If there were any minuses here, you would see minuses in this piece as well. And so all you need is the coefficients. You do not need to use any of the x's for the actual synthetic division part. And we're going to divide it by x plus 3. And here's the thing. When we divide it by x plus 3, you actually have to divide it by what makes that equal to 0. And so you have to divide by a negative 3 for your synthetic division here. So if you mess it up, most likely it's going to be because you don't pick what makes that equal to 0. And so here's how synthetic division works. The first number, whatever it is, it always just comes straight down. And then we multiply. 1 times negative 3 is negative 3. And then we add 8 minus 3 is 5. And you just repeat this process over and over and over till you get to the very end. 5 times negative 3 is negative 15. Add them together, you get 4. 4 times negative 3 is negative 12. Add them together, and you get 6. So this piece right here makes the quotient, and that makes the remainder. So the remainder for this question is 6. Now, in terms of the quotient is what you get after you divide. You are going to put your variables back in. So this was an x cubed. We divided by a single x, which means our quotient is an x squared. So you're going to have 1x squared, 5 x's, and a constant term. So your quotient is 1x squared, and you don't have to put the 1 there, but you can, plus 5x plus 4. And so it is a lot easier than long division because you don't have to mess with all the variables, and you just kind of eliminate that. But your answer here, you do have to know what power you're putting on each of these. It does go in order from square, linear, right, constant term. And because this was a cube, this one will start with a square. All right. So next question, some more synthetic division. It says use synthetic division to factor this x or 5x cubed plus 19x squared plus 11x minus 3 given f of negative 3 equals 0. Fill in the table, and then we're going to interpret the results at the end. So f of negative 3 equals 0 implies that this is a 0. So you do not have to change the sign. It's not a factor, it's an actual 0. So just like on the last problem, the factor was x plus 3. That was what we were dividing by. The 0 from that would have been change the sign, what makes it equal to 0. So we're going to divide this by negative 3. In here, you're putting your coefficients from your original polynomial. So 5, 19, 11, and negative 3. And then you're going to do the synthetic division. The first number always comes straight down. Don't do anything to it. And then you're going to start multiplying. 5 times negative 3 is negative 15. Add them together, you get 4. 4 times negative 3 is negative 12. Add them together, you get negative 1. Negative 1 times negative 3 is positive 3. Add them together, you get 0. So there is a remainder of 0, which means there is no remainder. All right, so part B says interpret the results. So we divided out the 0 at negative 3. So there is a factor of x plus 3. What's left over is this piece right here. It's going to be a 5x squared, a 4x, and a minus 1. If you were to multiply this out all the way, distribute all the way, you would end up with your original function. So what we have just done is we've used synthetic division to help us factor a polynomial that we wouldn't have been able to factor otherwise. All right, part C says give the complete factorization. So one of the factors is x plus 3. From here, x plus 3. The other factor, you have to factor this part, and you'll put those in there. So we need 5x squared plus 4x plus 1. We need to factor this. And so if you remember, when there's a number in the front, you multiply it in. So 5 times 1 is 5. They add up to be 4. So the two numbers would be multiplied to be 5, add up to be 4. Well, I wrote this wrong. That's why it doesn't work. I was like, wait, well, this isn't working. That's because it's a minus 1. My bad. That makes a huge difference. So they multiply to be negative 5, add up to be 4. Now that will work. That'll be a 5 and a negative 1. So x plus 5, x minus 1. And then for the factoring, because you multiply by 5 at the beginning, to include it, you have to divide both of these numbers by 5. So one factor is x plus 1. The other factor, this doesn't simplify, so what you can do is you can just move that denominator up, 5x minus 1. So your other factors are x plus 1 and 5x minus 1. If you were to multiply this out completely, you would end up with the original problem. One thing that I'm going to point out that I've noticed in the past is that you do all this, you get this part right, and then you put these two factors in here and you get this wrong. It's because you're missing the x plus 3 factor. You have to include it there as well. Even though you didn't have to do anything to factor that, it does need to be included in that piece. All right, so here is the next one. We have another synthetic division problem, and we're going to write the results in quotient plus remainder over divisor form, so that's similar to one that we did in the past. So I highly suggest you hit pause on the video and go ahead and try it on your own to see what you come up with, and then when you're ready, you can hit play, and we will go over it. All right, so x plus 5 means that you're using negative 5 because it's always what makes it equal to 0. Where's the 0 at from x plus 5? Your coefficients are negative 1, 2. We're missing the x squared, so you are going to put in a 0 there. So they do have to go in order, and because there's no x squared in our equation, there's a 0. 8 and 5. If that got you stuck and you started the video to watch that again, go ahead and hit pause if you want and try to finish it now. All right, so first number comes straight down. Negative 1 times negative 5 is positive 5. Add them together. 5 times negative 5 is negative 35. Add those together. Multiply again, we get 175. Add them together, we get 183. Multiply, we get negative 915. Add them together, negative 910. So yeah, these numbers just get really big, and they just alternate back and forth between positive, negative, positive, negative. All right, so here's the results. The quotient is based off of these, and then this one is your remainder. Because the original problem had an x to the 4th, that means this is going to be x to the power of 3. So it always just drops by 1. So this will start with an x cubed, and they'll go in order. So the results would be a negative 1x cubed plus a 7x squared minus 35x plus 183. And then the remainder, this would be technically a minus because it's negative 910 over what we were dividing by x plus 5. Sorry, you can't see that. There we go. If you put a plus here and then put a negative up here, that should be fine as well. Or you can just say that instead of adding that factor, it's technically subtracting it. All right, that is it for this section. The homework is in 2 parts. Like it's 2 sections in one homework. And so before you watch the next section, I would go ahead and get started on the homework and see what you can come up with and let me know if you have any questions.